application of a transistor. How to use a transistor as a switch. As you can see here, I have a battery, 5 volts, 4.3 kilo ohm resistors in series with a switch, right? Basically, when on this condition, the switch is open, there is no current flowing on the circuit, the switch is open. So when the switch is closed, there will be current flowing to the circuit. So there will be power dissipated on the load, and the circuit is active. Okay, now we can replace this switch with a transistor. In this case, we are going to use Q break N to analyze this transistor operation. I have here 100 kilo ohm resistor R2 and a voltage source, battery voltage source, BAT2. Okay, and here is battery 1, battery 2. So let us try to implement this in our PSPICE. So I'm going to name this BAT2 as my BS. Okay, and this one I'm going to name as B1 to make it more clear. So let's try to build it in using PSPICE. So I have here BDC, and then another BDC here. I have a 2 resistors R. Okay, try to rotate, and I have a transistor Q break N, right? Q break N is my transistor. So let me just try to build the circuit. I'm going to build this circuit. Okay, so actually we have here a procedure for you. This one, this is a tutorial for BJT application, and let's go first to our circuit. Let me just finish my circuit. So okay, we connect it here. This is our RC. Okay, so let us try to finish it and connect it to the ground. We have AG and D. Okay, so this is 5 volts. This is 5 volts. Okay, and this one is our B2. I'm going to name it as B source. I have R1 here, I have R2 here. So this is around 4.7 kilo ohm. Based from this figure that we are going to build, 4.7 kilo ohm. So Q break N, this will be 100 kilo ohm. Okay, so from here, from this procedure, we have to use DC sweep. We have to use DC sweep. We will have a variable voltage source here, BS, so that we can control the value of the base current here from 0 volts up to 5 volts. In this case, we are going to use DC sweep. So when we set to DC sweep, we don't need to change manually the value of voltage here. It will change automatically, right? Let's say how to set it, how to use DC sweep. We have analysis, setup. So we will go for DC sweep. Okay, click DC sweep. So what is the name of B source connected to the base? It is BS, right? And then we will start incrementing from 0 to 5 volts with an increment of 0.05 volts per increment. That's written here in our procedure. So now let's click OK, right? So let us first try to observe the current. Okay, what happened to the base current? So I'm going to click the, where's that one? The probe. This one, current probe. I'm going to put it here. This will give us the idea what happened to the current with this increasing number of voltage BS. So simulate. Okay, we need to save first. Save. Okay, so let us save it. Let's save it. Have it tutorial. Okay, tutorial. Let's say 22. Okay, it is now saved. Let's try to simulate. Okay, let's have a see what will happen. This is the waveform of this is the trace of the current base current. So it started from, as you can see here, at 0 volts up to around 0.7, here less than 0.7. The base current is 0, but after 0.7 and with the increasing number of BS here, so the base current increases, right? The base current increases. If the base current increases, now let us see what happened to the voltage here, the voltage BCE. So let me replace this with our voltage probe. What happened to our voltage BCE? Okay, let's try to simulate. Look at what happened here. BCE, right? When the transistor is operating in cutoff, okay, when the transistor is operating in cutoff, so this is open, right? When this is open, what we will have here is the total voltage of the source, which is 5 volt. So this is why here we have a 5 volt here. Now, as the base current is being as the base current increases, so this will enter active region, and we will have a value of BCE, right? So what will happen? This is the linear region. So what will happen? This voltage BC will be reduced linearly. Will be reduced linearly until it becomes almost shorted, right? Let us see from here. It will be reduced BC until it becomes the voltage is very less. It is approaches 0, right? When the voltage here approaches 0, it is on saturation mode. So if it is in saturation mode, we will have a maximum current flowing here. So we are using it as a switch, right? We are using it as a switch. So let us try to see also what happens. So this is the waveform of the voltage across BCE with respect to BS, and let us also see what is the current. What is the waveform of the current? IC. So we will have this current IC here. Simulate and look at what happened. The current, okay, starting from 0 at 0.7, it started to increases until it reaches this value. What is this value? More than 1, right? This is 0.8, 0.9, 1 point something. So what is that value? Well, supposedly it will be equal to, it should be equal to 5 divided by, it will be equal to 5 divided by 4.7 approximately. 4,700. Okay, 4,700. We have 1.06 milliampere. So let us see here what is, look at the waveform. It's more than 1, around 1.06 milliampere, right? So this is what happened to the current. So it is operating as a switch. Okay, it is operating as a switch. Now, the linearity of the waveform will actually, let us go now again for the voltage BC. Let us again go back to the voltage BC. Okay, this linearity will depend on how fast the transistor will operate in saturation, right? From open or from cut off to linear to saturation. This is at the point where it is already saturated. Now, if we have how to make it uh, in saturation, let's say we will change the value of R2. We will make it bigger, let's say 10K, and let's see what will be the effect on the voltage across C. As you can see here, it is more stiff, right? It's more stiff compared to, look at this one now, compared to 4.7, let us have 4.7 again so that we will have comparison. Simulate. As you can see here, look at the slope, right? Look at the slope here compared to the slope of the of this waveform when the voltage is when the collector collector resistor, the resistor across the collector is higher, right? When R2 is higher. Look at this one. Okay, if I even change it a little bit higher, let's say I make it 20. I'll make it 20. So let's simulate. Okay, it's steeper, yeah? It is more, it is steeper. So that means to say we can operate it as a switch. The transistor can be operated as a switch. Okay, there is a procedure here, by the way, there is a procedure here that you need to change the beta of the transistor. You need to change the beta of the transistor. Okay, so so that you can have you can set the duration at which it will become saturated, right? But how to change this VF? Now in this PSPICE version that we are using, so this is the old version actually. Here, if you right click this one, yeah, but the procedure here is that you need to right click and choose edit PSPICE model. In this PSPICE version, even if we right click on the Q break end, it will not give you an option. But let's take a look at the newer version, which is 17.2 here. If we try to right click here, okay, let's say here, right click, we have here edit properties, right? Edit PSPICE model. We have a lot of edit option. We have now edit PSPICE model. I click this one. Look at this. Also, nothing is appearing here. We cannot change anything here, right? Again, I will just right click. Right click. This is just for your knowledge. Edit PSPICE version, and one window will appear here. Okay, but we cannot still we cannot change. But let us try to check some other transistor. Let's say Q2N3904. Let us check this one. Let us check this transistor. We have right click, edit PSPICE model. Okay, here, look at this one. Look at the difference. There are some options where you can change the value of IC over IB. You can just set the value here, IC, then you can set the beta, right? You can set the beta. Okay, so that's it. So this is how to use the transistor as a switch, right? Because as a switch, you had to make it on and off. So you had to put a voltage source connected in series with a base current, with a base resistor, so that you can control the base current. And while controlling the base current, you can set the transistor in saturation, right?